Good afternoon, everybody. We're going to get started with the webinar here in just a couple of minutes. Let's, per usual, give everybody a few minutes to log in before we get started. And thank you, everybody, for coming. Okay, I think that, we've given it a couple 3 minutes and people can join as they need. So again, thank you, everybody. Welcome to our webinar, Make Managing Your Windows Virtual Desktop a Breeze with ControlUp. I'm Melissa Case. I'm the Content Marketing Manager here at ControlUp. I'll be your moderator today, and I'm really excited about hosting the session today. Today, we've got some great speakers with us. We have Esther Bartel. She's the Solutions Architect, a Citrix CTP, Microsoft MVP, and all-around amazing human being. We have Jim Moyle. He's a WVD Global Blackbelt and equally amazing. And Trentent Tye, who is the Technical Marketing Manager here at ControlUp. So before I hand the con, so to speak, over to Jim, who will kick things off, we've got just a couple of things to go over. So first, today's webinar will be recorded and available on demand after the session today. We'll send it to your email tomorrow. And then we'd love to hear from you during the presentation. If you have any questions for our speakers, you can send it through the Q&A and we'll make sure we get your questions answered. And we'll do our best to get to as many of those as we can. And in the event that we don't get to yours, we'll definitely make sure that we get you the answer that you need after the event. So without any further ado, as William Shakespeare once said, I will hand the mic over to Jim Moyle.
Thank you so much, Melissa. So it's lovely to be able to kick off this webinar. Now, as Melissa said, I work for Microsoft, and my area of responsibility is Windows Virtual Desktop. Now, I'm going to presume that a lot of the people, or in fact, most of the people who are here, who are listening to this webinar, have got a good grounding in desktop virtualization, and in particular in Windows Virtual Desktop. I'm not going to do a whole 15 minutes. This is basically how it works. If you need that sort of thing, there's a lot of resources on the internet, or you can always ask questions, as Melissa said, in the Q&A panel. So what we're going to go through is, as it says right on there on the slide, is the recent product updates. Now, this is kind of going to jump around a bit, and that's just the nature of the service that's had so many updates recently. We're going to touch on a few. There's a few that we're going to dive a little deeper into, and we'll take a few minutes around it. So it's going to be a bit sort of yeah. We're going to jump around a little bit, so forgive us for doing that. Now, it really has been a hell of a year, right? And it's been a hell of a year for Windows Virtual Desktop for many obvious reasons. It's exceeded everybody's expectations in terms of uptake by orders of magnitude. As part of that expansion, as part of the massive growth in Windows Virtual Desktop, we've also extended our control planes around the world. So we've got instances in Europe, US, Europe, Japan, Australia, Asia Pac, and Brazil. Those were some of the original locations. Recently, we've opened up South Africa, UK, France, Germany, Norway, and Korea. We've just opened up Switzerland, I believe, and the UAE and Canada are going to be by the end of the year. So wherever you live in the world, there is going to be an instance of the Windows Virtual Desktop service near you. Now, you don't need this instance to be near you. This is just to reduce latency and optimize things. You can place WVD VMs in any Azure location in the world. Now, there is something that is apart from these control plane locations that we're showing you today, which is the location of the metadata for the service. So if you configure your host pools, and then RDP settings on the host pool, that's where it's stored in the metadata for the service. Currently, that's in the US only. We will be bringing that out in the EU, hopefully this calendar year. And then actually, we're going to bring metadata locations out in other locations too. All right, so that's where we are available. Let's switch topics for not the first time and not the last time and talk about Teams. So this is the Teams flow for media, for audio visual through Azure. What we want to do is actually do some peer-to-peer communication like we see at the bottom there. And we want to be able to offload that media onto the endpoint. What we're looking at now is Teams running inside Windows Virtual Desktop in an unoptimized state. And let's have a look at the CPU on the right-hand side there, where we're hitting 10, 9, 12% CPU for this one instance to Teams. And we can see on the left there that on the left of the high-level architecture, that the rendering is being done on the server. The communication is being passed through Azure. With optimized Teams, then we get peer-to-peer connections with WebRTC between the endpoints, and the rendering is also done on the endpoint. So what does that look like now? We're doing exactly the same thing, but we're doing it in an optimized manner. And we can now compare to the CPU on the right-hand side there of less than 1%, down from 10, 12%. So it's actually averaging 1/15 of the CPU load running optimized compared to unoptimized. You can definitely still run optimized. You just have to beef up your servers to cope with the rendering on the back end. But it really is a step change. This new Teams optimization that we're looking at in front of us right now. So unfortunately, it is currently limited to a Windows 10 endpoint. There will be other endpoints being supported in the future. It's a question of getting those enhancements into RDP core, and that will actually release that that feature for all of the other clients which run on that RDP core. So if you've ever tried to deploy a Windows Virtual Desktop environment, you perhaps have thought, oh, I could do this a little bit quicker. Perhaps there's a streamlined way that I could do this that Microsoft could give to me. Well, if you're one of those people, we have an excellent solution for you. So brand new out is Windows Virtual Desktop Quick Start. And it can take an existing environment, or it can encapsulate completely a brand new environment. So this is wonderful for turning up to a customer, if you're a partner, or getting people familiar with the environment if you are an end user. And you can deploy and have ready in a matter of 20-30 minutes maximum, and that's including deploying AD, all the VMs, connecting it to Azure already, absolutely all the configuration ready for you to log on to. It's actually through an Azure DevOps pipeline, which is also a really interesting way to do it. And that sort of DevOps pipeline way of doing things we'll be seeing much more. So seeing as we're talking about deployment, how successful are people? What's the problems that I've encountered or we've seen encountered by people? So about 10% failure rate when people are deploying via the portal rather than a quick start. And about 90% of the failed 10% is failure to join the domain by VMs. So somebody has misconfigured the server's account or typoed the password for that server's account, and those VMs hadn't joined the domain. But very, very high success rate apart from that particular issue across the board. And we can see on the right hand side that it's across the world in terms of number of VMs in those different deployment locations, and those are the top ones that we've got there. Another new thing, Microsoft Defender Advanced Threat Protection. So the built-in Defender antivirus has improved hugely over the last few years. You can have a look on independent sites like av-test.org. They've got a whole lot of really useful independent comparisons for different security bits of software. You can really consider using endpoint detection and response. You need an E5 license for that. It's now in preview for Windows 10 multi-session for up to 25 users, which seems a reasonable number of users per host. I usually see sort of 15 to 25 users per host, but just bear in mind that there is that limitation there if you're using larger servers. Network protection, blocking connections to malicious destinations, web content filtering. You can disallow access to unwanted content, attack surface reduction, targeted countermeasures against prevalent threats. Really, really good. If you have never used it before, then you should take a look at it. There is secure scores available. So this provides recommendations and best practices for increasing your security posture. These recommendations come weighted to help you prioritize which ones will have the biggest impact. And we even give you sort of quick fix options in there to make sure that any problems found can be addressed really quickly. With WVD, security is really important. Of course, you've got reverse connect, you've got all kinds of built-in Azure security. it is really crucial not to just protect the individual sort of desktop VMs, but all of the surrounding infrastructure as well. So you really want to get to know the Azure security ecosystem and use it to help your secure your WVD deployment. Now then, images. I told you we were going to jump around a bit, and we are, but that's okay. Hopefully everybody's still keeping up very well. Shared image gallery. Now, if anybody's ever done on-premises desktops, virtual desktops, they'll know that making sure that your golden image is properly versioned, is properly replicated, you've got a handle on where it is and what's been happening, it's always been a problem. Shared image gallery is an Azure service which will help you solve that. And if we take a look at what that looks like in the portal, we can see we can give it a name, we can give it a version, and if we look a little bit down inside the portal, we can give it replication locations and indeed make sure that we've got the correct storage type underneath it to help support your deployments. Part of the shared image gallery, because it has versioning, means that if you encounter an error or you've got some, for whatever reason, you need to roll back to the previous version, right? That's where versioning really comes in handy. You can roll back to wherever you need to do so. It also supports a tag which is latest. So you can say just deploy latest. You don't have to know the exact version number. You just know that you want to have the latest image. And shared image gallery supports that as well. One of the other things that I get a lot of questions about is the quick assist or shadowing. How do we shadow users inside WVD? And quick assist is the way to do that. So we're going to have a look at this, and we've got a virtual desktop, and the background desktop is your support professional. So we're going to try and get some assistance, and now we're going to get a nice security code that we can type in to make sure that we're connecting the right person to the right user. So we're going to enter the code. So that's 928111. And we're going to share the screen with our support person. Now, this is going to set up the secure session encrypted between the user and whoever's supporting them, and they can either take full control or just view their screen. And that's going to be told to the person on the other side, and they have to allow that. So should be compliant with regulations, making sure that privacy is respected for your users. And now we have the ability to full control. Look, we can look at the taskbar. And it turns out that in this case, Microsoft Edge is consuming a whole lot of CPU. So let's kill that for the user and return their VM to a usable state. And then once we're finished, let's close that. We'll get a notification that that now the screen sharing has ended. And a great way to be able to support and help your users. So let's move from shadowing to scaling. Now again, scaling is another topic that I get asked about all the time, and scaling is something we're going to talk a lot about. I'm going to talk a bit more about it in detail, and then when we talk about the new ControlUp features, also useful. So scaling is a big important topic right now. We have some new scaling that we have released for Windows Virtual Desktop. You can scale differently whether you're in peak hours or you're off hours, number of sessions, number of cores. It all runs serverless through autoscale runbooks, and that is now GA. You can go to the Windows Virtual Desktop documentation, have a look at how to install that, and because it's all PowerShell and it's all in runbooks, If you want to change this, if you're happy enough to do so, then you absolutely can. Which I really love, that it's not a black box and you can modify however you want to do this. So from scaling to starting, another thing that's been really requested is starting a VM on connection. The ability to have a VM off and deallocated, so you're only paying for storage, you're not paying for that compute. And then when it's needed, you can start the VM once that user logs in. Now, VMs starting in Azure are pretty damn quick, but obviously this will add on to that logon time, because you've got to start that VM, it's got to register with the broker, then you've got to connect to it. So enabling this will save you a lot of money, but will add slightly to your login time. A trade-off which is very much worth it for a lot of people. And we can see that this demo around the host pools, we've just got a radio button there, start VM on connect, highlight that, and we're off to the races. Now, stuff that's coming, but I'm not going to talk about, I'm just going to briefly mention. These are on the public roadmap, which you can get to that short link, WVD roadmap. PowerShell commandlets, migrating from the WVD classic version to the current version. MSIX app attach. I could spend a whole hour just on that topic. And now also Azure AD support for VMs. You can go and look how all of those are doing in our public roadmap. And there's more stuff on there as well. Now then, you know, I said we would talk a lot more about scaling. This is some work that I did for a community event a little while ago. And the reason why I'm pulling up that work that I did now is because it's particularly relevant to what ControlUp's going to talk to you about in a few minutes. And it's about the end of day. What happens to your multi-session VMs at the end of the day? Well, if we'll have a look at one, so in blue is your users. So this is 16 users per server, and the red square is a server or Windows 10 multi-session VM. And we saw all 16 users calmly logging off in order and going home, and we can switch that off. But we all know users don't log off nicely in order. They log off at random times, which if you've just got a single server, doesn't matter. They all go home, you turn your server off, you save your money. But I think we've all got more than 16 users. Well, what if we've got 512 users? So this is now 32 VMs and 512 users, 16 users per server. We've had our maximum concurrency. And now it's the end of the day and people are logging out at random and going home on a Thursday afternoon. Maybe they've got to go and vote. And 25% of them have logged off and gone home. We can't switch anything off. In fact, we're nowhere near switching off a server yet. So let's let a few more people go home. Let's see when will we be able to switch off our first server, and when will we be able to switch off half of our servers? And I reckon that half is interesting because we've had half of the users leave, but we don't have half of the servers off. So let's carry on logging people off. And think in your head, what percentage gone shall we turn off half of our estate? It's certainly not at 3/4 gone, which we see here.
You're making me very nervous, Jim.
We could switch off our first server here at 78% gone. But that's not saving us a lot of money, right? We want to save, like I say, 50% of our running costs. How many people do we need to have logged out? Well, quite a lot of people are logged out and we haven't turned much off yet. What was that number you thought in your head and the percentage of people who had to go home? Because the real number is 96%. And there's only 21 of those 512 users left in the environment before we can turn 50% off. But I made this slide in PowerShell. I didn't write those animations by hand, right? And I did it random. So maybe random chance is affecting this. So let's run it again. So, but let's run it at 4x speed. Maybe it's a Friday evening now, and everybody's needs to get to the pub. So as you can see, this is a different pattern of VMs being turned up because we've re-randomized it. We had 19 users left before we could turn off 50% of the servers, and that is the same again. That's a pretty big coincidence. Okay, but it's 96% of people who leave work before we can turn half the servers off. Well, let's run that simulation 98 more times for a total of 100 times. And this is the number of people left before we can turn 50% of the users off. It's pretty consistent. It's maybe not 19, it's maybe the average is 22.5 or something like that, but it is consistent. That still works out as 96%, by the way, because it's 512 total users. What if I change it? So this is all 16 users per server. What if I change the number of users per server? Well, what if I run it 100 times, but with 256 users per server? Well, it turns out that when you're rounding to 1%, you got 256 users per server. You need 100% of people to log off before you can turn 50% of your infrastructure off. What about 1 to 8? Oh, that rounds to 99%. 64, still 99%. 98 for 32, now 16. Now this is what we saw, right? This is our run. So 96%. And then let's go down to single session, so 1 user per server. And then you got what you absolutely know must happen, right? 50% of your users log off and you can turn 50% of your infrastructure off. What's important here is that it gets bad really quickly. So even at 8 users per server, we can still have to wait till 92% of our population is logged off before we can turn 50% of our servers off. I wondered if there was an equation for this, and it turns out that there is. So here's the equation results in orange compared to the simulation results in blue. That's a pretty good match. So let's use the equation. So what is this? It's E is the probability that a server is empty. P is the probability of a single user being logged off, and U is users per server. Why is this so useful? Well, for one, it tells us something very important. All of these graphs are completely independent of the number of users in your environment. So whether you've got 100 users or 100,000 users, the problem and the graphs will look identical. That's interesting. It's really interesting. So it's putting stuff in drain mode doesn't really help that much. You could put the hammer down on your users and make them log off and log back on again. But it's this bit you really want to attack, where you've only got a tiny percentage of your users left on the system, but you're running a huge amount of infrastructure to support them. This is where we can really save some money. And this is exactly the problem that Trent is going to cover and attack when he talks in just a second. But before we get to Trent, we have Esther next. So are you there, Esther? Let me make you the presenter.
I think you want to make Trentent the presenter, so
Okay.
I'll let him handle the slides and just pitch in wherever I think I can contribute.
That sounds amazing. So Trent, thank you very much.
Great, thank you, Jim. All right, just want to get a check. You guys can see the screen?
Yes, we can.
Perfect, okay. So thank you for the introduction, both Melissa and Jim. So I'm Trentent Tye, I'm technical marketing at ControlUp, and I'm partnered here with Esther Bartel. She's, as was mentioned before, CTP, MVP, like vExpert, expert in the field. She's been working with us at ControlUp on our WVD script-based integration, and she's done a wonderful job. And I just want to thank Jim for all the work that he's done for WVD and that wonderful presentation, leading to one of the most important things we think, which is saving money with WVD and actually managing and monitoring it. So before we get started there, I want to just introduce ControlUp, who we are. So if you have not heard about us before, we're a global company. We've got over 1,000+ customers. We support all the major platforms. So if you're running Citrix on Azure or on WVD or any of those other platforms, we support all of that along with you. And obviously we're a Microsoft WVD partner, and this is kind of what this presentation is about, and we're strong in that space. So what we do is we do synthetics logons, availability testing. We have automation in our platform. Esther is a part of the wider community, and we engage with our community to bring in their expertise to help us at ControlUp and remediation, troubleshooting. Obviously, you can see everything we offer. And this is just a quick overview of the architecture of how ControlUp operates. So we've got our console product. That's our real-time console. It runs locally to your servers, and it pulls all the metrics and the real-time information there in a grid view that we'll go over in a minute. So we connect into all the major hypervisors. We're connecting into the public clouds through our script-based API to start, and we'll show you some of those actions and how they all play together. So I'm just going to hop straight into some live demos, excuse me, that will highlight the features of ControlUp and kind of what we can offer with WVD. So I'll start with excuse me, some performance monitoring and optimizing, and then we'll get into the ControlUp automation engine that helps us achieve all of this. So I'm switching over now, and we're on the ControlUp console. And what you can see is we've got our WVD machines here. You can look at actually our operating system that actually tells us that it's the Windows 10 for virtual desktops, Windows 10 Enterprise for virtual desktops. We can see we've got multiple users on these machines. And if I double click, I can actually drill down, and we can see all the stats and all the how all of the users are doing. All of these metrics are being updated every 3 seconds, so everything is getting pulled accordingly. So if we look at like here, I think there might be an interesting guy. So we've got a guy here actually watching, a YouTube video, and all of this is being done live. Jim actually made mention of shadowing. So shadowing is actually a feature of ControlUp. We can actually get session screenshots without notifying the user, with user approval or with user notification, and that's all configurable within our security policy. So that'll actually, if your organization does not allow your IT admins to do something like that, then we can. So we can see this person is watching, looks like some ongoings that are happening in the world today. So if I go back, one of the things that we can offer to help our performance troubleshooting and our monitoring and optimizing is, if I'm looking at this user here, I can see he's running like a Adobe Acrobat. He's got some processes going on here. I'm actually just going to tweak this guy down to normal. So what we have in ControlUp is we've got our automated action that allows us to actually monitor specific processes, and if we find that they require some additional oomph, we can actually adjust things like the process priority on the fly. And we can do that by actually measuring a WVD specific metric, the user input delay, and this will actually tell you how responsive your application is. So I'm going to bring up this guy's desktop, and so we can see he's running a 3D model, and as I'm manipulating it, it's going to consume some level of CPU. You can see the user input delay is 125 milliseconds or so. So it's not the best experience, not the worst experience. It just is an experience. But one thing we can do is we can actually pick up that the user input delay is high, and we can actually adjust the process priority. So we've detected that the user input delay had exceeded some threshold, and we adjusted the process priority accordingly. So the user input delay, it measures everything in your UI. So how quickly everything changes. So as I'm moving the mouse over these menus as they display, it's actually measuring how long this menu is taking to draw and then return back to you for your user input. So this is actually a way you can actually measure your user experience in a very real, very substantial way and remove the network from the equation. So we think that's really powerful. Another optimization feature of ControlUp is we can actually take this session and we can actually do some optimizations on it. So if I disconnect this session, ControlUp is going to recognize that the state has changed to disconnected, and it's going to run 2 optimizations. One, it's going to reduce the process priority of all the processes here, And then another is it's going to shrink the amount of memory this user is consuming. So if we watch the memory working set and the process priority, we'll see both of them get changed. And so if you're on a multi-session machine, this is one way, boom, you can see how other users now get more access to the resources on those machines. They get more CPU because these processes are now consuming less on their process cycles, and they get more memory available to them because now this is being paged out to the page file. So real RAM available on that virtual machine is now available for other users to optimize their performance. And then again, if you reconnect into this session, all of this goes back to exactly what it was previously. So the memory starts getting paged back in and the process priority gets set back to normal. So how we actually operate that is if we look at the trigger-based system we have. So this is how our automation actually happens. I'll see if I can just find this. So we have quite a few. So what we do is we're monitoring the session state. So we're looking to see if it goes into a disconnected state. If it goes from active to disconnected, we can set our scope, and we're running these two actions. So we're adjusting the process priority based on the session state. So it'll detect if it's in an active state or a disconnected state, and it'll adjust those process priorities automatically. And then we can also trim the process working set. And that's exactly what saves you your memory consumption on that session by trimming out all the processes in that session. I mean, it makes sense, right? User's gone into a disconnected state. Odds are they're gone for lunch, or maybe they went home and they just didn't log off. They're consuming your resources. And this is one way we can actually reduce their footprint among your users who are actually being productive on those servers. Okay, so let's go back. Okay, so that's performance and monitoring, and that's monitoring and optimizing environments in WVD. So let's talk more about in-depth about what ControlUp and WVD can do. So we're going to talk about how we integrate into WVD. I'm going to hand it off to Esther, and she's going to talk about the capabilities that ControlUp can offer for you in your WVD environment. And then we'll talk about some superpowers on how we can really save you real money by really optimizing that cycle that Jim was talking about, that user cycle of users being on servers and shutting down those boxes. So to integrate into WVD, we actually do a script-based integration. So in our GitHub, we've got these environment synchronization scripts. You download that onto your ControlUp monitor, and then from there, you set up your credentials to connect into WVD, and then from there on, ControlUp will automatically sync your WVD environment into ControlUp. And then it'll also automatically pick up that it's a WVD machine and expose a whole bunch of those integrations and script actions that Esther will talk about in a second, all automatically for you. So we have our GitHub, we've got our support site that you can actually see here that walks you through how to do it. And we have video material as well that you can actually watch, and it'll show you step by step in video on how to do that. Okay, so for the capabilities, I'll hand it off to Esther. Esther, you want me to change you to be the presenter?
Yes, please. Then I will share my screen. So let me see if I can quickly share my screen. That wasn't the one. So what I wanted to talk about is some of the capabilities or script-based integrations that we built for WVD. As Trent already mentioned, we wrote this very awesome script, if I say so myself, to make sure that you get your host pool and session host structure imported into the ControlUp console. So if you want to have the same hierarchy within your ControlUp console, then you can definitely use that script, and feel free to have your session host structured so you have a visual confirmation of how your session hosts are part of which host pool. The
Esther,
other thing, yes?
I can't see your screen. Are you sharing?
Yes, I am. I thought so. No, it says it's paused. Hang on. Let me see. Is it sharing now?
Yep, we see it.
Okay, perfect. Thank you very much for noticing that, Jim. So what I was talking about was the fact that we have this awesome structural tree within the left pane of the ControlUp console that reflects the how the session hosts are added to the different host pools within WVD. One of the things that I love about ControlUp is that it allows you to create your own script actions. And I've used that system to make sure that I get some WVD integration from the start in ControlUp as well. Because ControlUp focuses mostly on the session host, I had to make sure that I kind of changed. Let me quickly switch over to this one to make sure that I keep track of the story. So first of all, if you want to do some automated actions against Azure or Azure, you need to have what they call a service principal available, because that allows applications to interact and authenticate themselves against Azure without having any pop-up or interactions where it's asking you for username and password. So we definitely added to our knowledge base how you need to set up your service principal within Azure and how you can use it within ControlUp. So what we did is we created a script first that allows you to store in a secure way your service principal credentials. So you only have to enter them once per user per machine that is running the ControlUp console. But after that, it will be reused by all the additional WVD scripts that we created within the console. And as I mentioned, ControlUp is mostly focused on monitoring virtual machines and virtual appliances within your infrastructure. So instead of the focus where WVD starts with a host pool, I had to kind of flip the picture a little bit to make sure that the session host is now the centralized part in the system. So what we did is we made sure that the WVD script actions that are available you will always be able to run them from your session host. Even if they are scripts that are mostly focused on a host pool, we made sure that in the background, the session host is translated to the right or linked to the right host pool, and the actions are performed on your WVD host pool. So let's get back to our console. And I hope this is very visible for everyone as it has the right scale. So as I mentioned, you can build your own script actions based on PowerShell or batch files or whatever language you prefer to make sure that you can add your own automated actions or scripted actions that allow you to do some additional management of your session hosts in this case. So for WVD, we wanted to make sure that you didn't have to switch from the ControlUp console that gives you immediately all the different metrics of the system to the Azure portal to perform any remediation actions that you want to perform, or just to retrieve some troubleshooting information that you want to have from the WVD environment. But we wanted you to enable you to retrieve that information and to perform those actions directly from the ControlUp console. So the most basic ones are the retrieval scripts that we wrote, for instance, to get all the session host pool information from all the session hosts information that are part of a host pool. So it might take a little while because one of the things that we made sure is that the script will also install any dependable PowerShell modules for you if they are not already installed on the system. So as you can see, we are providing all the detailed information on losing my notes here. Excuse me. So we are providing all the information on the session host that you can see in the Azure portal as well. But we also try to add a little bit of extra information that is available through the API, but not at the moment visible within the portal in Azure itself, like the agent version, the OS version, and even the last heartbeat that will give an indication on whether or not the service is responding correctly. So going to a couple of other scripts as well. And because this is the demo environment, I am filtering on the WVD specific scripts. So one of the other cool things that we wanted to provide is to give you a quick option to immediately see what the configured image is for your host pool. So in this case, what I'm doing is I'm retrieving through the API all the information that is currently configured on the host pool from image. And the reason why I'm doing that is, for instance, if you're working with the shared image gallery and you are working with versioning, this allows you to quickly see whether or not you are still running the latest version on your host pool and the session host within the host pool. Of course, we wanted to make sure that you're not just able to retrieve data, but we also wanted to make sure that you are able to actually update configurations or perform administrative tasks, like in this case, setting the drain mode on the session host, or at an host pool level, setting your, and it's probably on the next screen, setting your max session limits, for instance, because this allows us, in combination with the triggers and the automated actions that Trent showed earlier, a way to adjust those numbers if we see that any compute or any resource whether there are less resources available. So we can tune the max session limit down, so the load balancing algorithm will take that new number into account. One of the other things that we wanted to do as well was to also incorporate the different WVD backplane services that are available. Like the option from the Azure portal to easily send a message to your user and the user session within WVD. And the reason why I'm just doing that through WVD is that I do not have to have a direct connection to the host to be able to still send messages to the users. So in this case, because I'm using the user principal name to send a message, it's even detecting that there are two sessions used by my user. So it's sending the message simultaneously to all the different sessions of that user. And as you can see, it's just a clear message that is being sent. And last but not least, and this is one of the scripts that I'm basically know that we still need to release, but that I just finished the work on, is we have the option to now also use the WVD start session host and stop session host actions. The reason why I created that is that Trenton challenged me to consider cost management and auto-scaling capabilities from ControlUp as a remediation action. And because we realized that if we would use the built-in option for power management within ControlUp itself, we would only send a shutdown command to the system itself. And for those of you who are familiar with how Azure works and how compute is assigned to virtual machines, you know that if you send a shutdown command to a virtual machine within Azure, it will definitely be powered off, but all your compute resources are still allocated to that virtual machine, which means that Azure will still charge you for consumption of that compute that is allocated. In order to make sure that you stop a virtual machine within Azure, you need to actually either go to the GUI to actually hit that stop button, because it will also deallocate the resources. And that also means, as a consequence, that if you start that machine, that it will be assigned new resources. So if you need it to be persistent, then that definitely is not an option. But especially for WVD, where we're talking mostly about non-persistent systems, please be aware of the fact that it is more smart to stop a machine than just to shut down the host. So that's one of the reasons why I wanted to make sure that we can offer an actual stop command and make sure that the resources are deallocated and some costs can be saved. That's basically most of the demo that I wanted to share. Trenton, do you want me to make you presenter again?
Yeah, I think I can take it. Awesome.
Oh, perfect.
Thank you so much, Esther. Yeah, that's been absolutely phenomenal, both the work you've done and what we're actually capable of now. So I want to jump into, I guess, a little bit more. This was what you showed. All right. Just to be clear, you guys can see my screen, yes?
Yes.
Okay.
Yeah, we're good.
Okay, good, cool. So what Jim showed you with the users logging off, there's actually a little bit more underneath the surface of it as to how that works. Is that if you're an IT admin, then you're probably familiar with these little tricks or policies, but if you're not, then I'm going to pull back the curtain a little bit as to how users go from an active state to an idle state to a disconnected state and then subsequently logged off. And they do that with timeouts. And those timeouts are group policy options that you set. And so here's an example of the first one. So this is your idle timeout. So this is how long you want to set a user to be idle before they get moved into a disconnected state. And so you can set the time limit there. Obviously, most organizations, I've found what they tend to do is they tend to set the idle and disconnect session limits based on the business needs. So if users want to walk away from their desktop for a couple hours, you're going to set this for 2 hours. If users, if they're commuting to the office and back and they want to have that ability to reconnect to an existing session, you're going to set that session limit according to that. When I worked in healthcare, we had really aggressive ones of 30 minutes and like 15 minutes, so 30-minute idle and 15-minute disconnect timers. And what ended up happening is that our user community kind of revolted on us because they couldn't even go for lunch without getting logged off and then having to restart their entire session. So we had to extend that to be 1 hour idle and then 30 minutes disconnect. And so this is the idle one, and this is the disconnect policy. So this is how they work. You can see that they're not really granular. You can't set like 90 minutes. You can't set 45 minutes. Little secret here, actually you can. These are actually just setting some registry keys that you can modify. They're just registry D words, I think, that are within your system. Now, the challenge is if you set these timers based around your business needs, at the end of the day, when people go to log off or when people just walk away from their machine and let their session just idle and expire on its own, is that you get something that looks like this. So I asked our ControlUp research team to pull out some data, and this is what they showed me for organizations. This is how generally they operate. You got your, your user rush in the morning. It kind of peaks around that 11 o'clock time frame, and then people go for lunch. You get a bit of a dip, and then it comes back up. And you can see how they all flow with each other. You can see that there's an idle that's always kind of consistent, a disconnected user state that's kind of consistent. And this is real data that you're looking at. So this is like the aggregation of what we see with our customers. And so for the most part, this is kind of what you experience. And the problem is that these users here, these gray and red area, they are eating your, well, they're eating your money essentially, because 4 o'clock end of business day, someone walks away from their machine, they go into an idle state, then they go into a disconnected state, probably sometime down here. And you saw what Jim showed, where you need a large percentage of your community to be logged off in order for you to start saving money, or to be able to start shutting down those machines so you can start saving money. So you can see that with long idle timeouts, it becomes really difficult. And now the challenge is that if you set those timers according to your business needs, you can't adjust them afterwards. Those registry keys that set those timers are read when the user logs on, and they're not read again. So you can't just modify it and then have existing user sessions get a new timer. So just again, to focus, these are the users that are causing us to spend money, essentially. So I'm just going to talk about the lifetime of a typical session lifecycle of what a user goes through. So we kind of saw it there. You know, they're active in the morning, they're idle for lunch, they're active in the afternoon, and then if they just walk away from their session, which a lot of people tend to do, you get this idle and disconnect timers. So in this particular example, I'm using 2 hours idle, 2 hours disconnect. So it goes from idle and then it gets moved into the disconnected state and then it's logged off. So that's 4 hours worth of time that's being consumed there at the end. And so when you look at what a session lifecycle looks like with a multi-session server, we now can kind of see kind of what Jim was showing, where those user sessions aren't logging off altogether. You can see that there's a big chunk that kind of log off at the start because it's the end of the day and they're following, you know, proper policy, or they're walking away or whatever. But then you have sometimes these users who maybe they started late, or they're trying to finish a project, so they're working a little bit later than normal. You know, they get pushed, and they push that shutdown time. They push that time on that machine. You're not going to log off this active user because that would be very disruptive to them. And if maybe they're just offset in their start time, so that would be really not a very good user experience. But what we can do, so this particular user is the one causing us problems. What we can do is with ControlUp, we can do something called sliding timeouts. So even though you can't change the registry values on those users, so you can't change their actual timeouts, we can use ControlUp to change the timeouts for us by leveraging the ControlUp metrics. So this is before sliding timeouts, and then the new feature, the new automation we're going to introduce is sliding timeouts, and so this is after. So now you can see, and you can see I've denoted end of business day here as this white line, how much time we're saving on this machine being running. So what's happening here is that we're saying, okay, after the end of business hours, we've adjusted our timer for 1 hour. So any user who has been idle, they now get 1 hour as opposed to 2, and disconnect timers are also reduced to 1 hour instead of 2. And then after that hour, so if this was 5 o'clock and this is now 6 o'clock, we've now adjusted the timers to be 30 minutes. And so now you can see that we go from 30-minute idle to 30-minute disconnect. And after that, we adjust the timers again. So now we're doing 10 minutes, I think, here. So now we have 10-minute idle, 10-minute disconnect. So if you're familiar with, you know, your phone, your smartphone, or something like that, your processors have something called race to sleep. And so they'll try to accomplish all of the tasks that they're asked to do on their processes as quickly as possible, and then they go back to sleep. So that way, they're saving you battery life. But in this particular example, we can save you money by racing these sessions to close. And what we're really interested in is doing that in sessions that are not being productive, that users have gone home, or that are idling themselves out. And if we can reduce those timers, then we can start saving some money. So this is kind of what it looks like with an overlay. Again, you can see the amount of money being saved here, like 1, 2, 3.5 hours worth of time. And if you times that by, like Jim showed, 16 servers, you know, 3 hours at whatever, $4, $8 an hour per server times however many days, this can add up really, really quickly to some massive savings. So how do we accomplish this? And within ControlUp, we'll use our trigger system and our script-based actions in order to accomplish this. So if I look at the triggers, we can actually see I've got some WVD triggers created here. So we've got 60-minute, 30-minute, 10-minute timeout. So what this is looking at, if I edit it, is we're looking at the session state. And for the 60-minute timer, we're looking at if the session is 60 minutes, 70 minutes, 80 minutes, 90 minutes, all the way up to 120 or more with our 2-hour timer. That's what we set it to. If the idle time that session equals any of this, and they're within the WVD folder scope, which means the machines reside within here, and it's after 5 p.m., then we're going to run active idle disconnect. So this is a script I wrote that will be published on the community soon. that it'll read the session state and it'll just move it to the next one. So if it's active, it moves it into a disconnect state. If it's in disconnect, it'll move it to a log off. And so you can see we do that for 60 minutes at 5 p.m. We now have 30 minutes going up to 60, so that way these two can overlap. And here we focus on the WD folder, and you can look at the schedule, and again, we're targeting after 6 p.m. And for the 10-minute timeout, the most aggressive one, again, we're going from 10 minutes to 30, and here we're going after 7 p.m. So we're setting that on all of our WVD machines, but if you wanted to target specific machines, you can certainly target subfolders. So if you've got, one or two machines you want to have available all the time, so that way users can always have that as a long timer because that machine never gets turned off, so you have high availability. You can organize your structure in such a way so that way it is not targeted. And so then once that occurs, once all the sessions are logged off, we work in conjunction with the WVD auto scale script. So the WVD auto scale script, checks every 5 minutes, 3 minutes, every 10 minutes, something like that. And it's looking for that there's no user sessions in order to do its stop. So we can actually execute on that faster. So because we're a real-time console, real-time metrics, once a user is logged off, we detect within 3 or 4 seconds that there's no user sessions on that server. And when we do that, we can actually execute one of the scripts that Esther has created. And that is so we're looking for user session equals 0 against a machine. And we're looking at that again in the WVD folder. We're looking at that after 5 p.m. And once that occurs, we run our WVD stop session. So this will actually stop the session host and deallocate it. So as soon as that user count goes to 0, within just a couple seconds, boom, we're shutting down that machine, we're deallocating it, we're maximizing our savings by minimizing the amount of time that machine is running when it doesn't have to be. And we think this could be really big for people who are running WVD or running really any kind of cloud service where you're getting charged by consumption, just like you are here in that particular scenario. Okay, so we kind of went over the automation on how we can do resource optimization with the user sessions getting disconnected, and we're shrinking down their CPU utilization and their memory utilization. We can do automatic remediation, where if we detect that there's a fault in the environment, we can automatically run a script to resolve it, and we can do augmented troubleshooting as well, where we actually pick up errors. So if you detect that there's an application crash, we can create a process dump automatically, stuff like that. So that way, if you need more information around a problem, we can provide that. And then as well, we also offer our ControlUp Insights product, where all of the information from our ControlUp console and our real-time product gets uploaded to Insights, where you can then track things like exactly what I showed you with the session states, along with other information like application launches and who's using what applications and so on and so forth. So I just want to say, thank you to Jim, thank you Esther, you guys have been absolutely phenomenal. Thank you everyone who's hung around to the end here. Download ControlUp from www.controlup.com. It's completely free to trial for 21 days. After that, we'll reach out, or if before that we can reach out and we can start talking about how we can help use ControlUp in your WVD environment and help you actually monitor and manage your environment and your resources within that environment more effectively. So with that, I think I'll pass it back to you, Melissa, and just say thanks for that.
Absolutely. So thank you, Trent, Jim, and Esther. You guys are fantastic as always. And thank you everybody for attending. If you've got any questions, feel free to shoot us an email and we will get your questions answered as quickly as possible. And again, you'll get a copy of this recording in your email tomorrow. So that is it. Thank you for joining us, and we will see you again next time.